Next, what we're going to do is we're going to look at how to divide complex numbers. Basically, what we're doing is we're rationalizing our denominator. So what we need to do is since it's the square root of -1, it's the same thing as a radical. And we, of course, can't leave answers with a radical in our denominator. So what we're going to do, pretty basic stuff. Just like before, when you're rationalizing the denominator, you want to get something that will get rid of the radical. So what we would like to get is we'd like to get 3i squared. Because if we can get 3i squared, we know I squared, same thing as -1, and that will basically get rid of our radical. Well, for us to do that, what we're going to do is we're going to multiply the top and the bottom by I. So 2 times I is 2i, and then 3i times I is 3i squared. So when you simplify this, you'll get something that looks like this. And again, that negative sign, properties of fractions here, it looks like this. You can also rewrite it -2i over 3. Or you can make it -2i over 3. All three of those fractions are equivalent, so just make sure that you realize that. Looking at our next example, this time, unlike the first example where we had a monomial in our denominator, and now we have a binomial in our denominator. The good news is the steps we're going to take to rationalize this denominator are exactly like the ones we did when we had a binomial and a radical, and that's to multiply by the conjugate. Just a little quick reminder, the conjugate, the same two terms, different middle sign. So we're going to multiply the top and the bottom of our fraction by 2 plus 5i. When you distribute, what you should get is 14 plus 35i, and then plus 8i, and then lastly plus 20i squared. In our denominator, we're going to get 4 plus 10i minus 10i, and then minus 25i squared. All right, so what you have to do is tidy up just a little bit. Our whole goal, of course, is to get rid of our fractions. So we should know, not get rid of our fraction, but get rid of the radical. We know I squared. I squared is -1, so both those will look like that. When you combine like terms, I'm going to go ahead and put my constants together. And that will give me -6, and then plus 43i over, these two things will cancel, and then I'll put those two together and get a positive 29. All right, so yeah, what I would need to try to do at this point is to try to simplify my fraction. If I could do that, fantastic. If I can't, then there's nothing I can do. I don't believe there's a common factor between 6, 43, and 29. But let me also show you kind of what the book will do in terms of a problem like this, is they will write it as in a complex number form. So what they'll do is they'll write the real part first. So they'll take the 6 and divide it by 29, and then they'll do the imaginary part and say 43 divided by 29i. So just realize those are equivalent to each other. It's just the book is going to write it in complex number form where you have the real part first and then the imaginary part. I'm okay with you leaving your answer like this, though. That's okay with me. But just realize if you're trying to match it up with something as a multiple choice or something, it could look either way.